So on the third part, right? So we'll be taking up any of the questions that you had, any discussion points that you wanted to ask to our speakers, right? So again, to give you back a recap introduction, we have Srinivas over here, we have Kuldeep, we have Aditya, and we have Robin, right? So any of the questions that you have that you have noted down throughout the talk, so this is the best time to start off with, right? Okay. Do you have any questions? Well, uh,
Yeah, the micro VMs thing. Correct me if I'm wrong here. From your talk, right? My understanding of what this Open Nebula thing is that it's like a hypervisor where you can use it to spin up VMs, micro VMs, and also containers, right? So it's kind of like an all-in-one solution that does everything, like that handles like containerized containers, VMs, and micro VMs. Is it that? I just wanted to understand that.
Yeah, it's actually that. It provides an end-to-end solution to
Okay.
any kind of hypervisor you want to use on top of your underlying node cluster.
Okay. So it's like it's kind of like Docker desktop, but like on steroids.
Yeah, something similar, but
Yeah.
it's more manageable
Yeah,
because
okay.
we can handle everything right from the networking to storage to
Okay.
CPUs from there.
Does it also handle orchestration? Like, does it like if you like spinning up more containers depending upon your load and everything? Does it also do that, or
It does not.
so it doesn't handle. So how would you use it for? So because that was my one question, right? Is from everything you said, it's good for like a data center type thing where you have like clients and there's only like one instance, you're never going to see load. But if there is load, how would Open Nebula be useful if you see load?
Okay, so to answer that, I have a few points. First of all, because of the fact that you are using micro VMs, so readily we don't move micro VMs over to different nodes that readily as compared to containers. Also, because of this particular problem of Open Nebula itself, because first of all, with Open Nebula we were solving our data center issues. When it comes to handling node, because of which we have developed our health monitoring service, a custom application, which will in turn go ahead and do it. Also, it is something like, for example, there is a micro VM that is not using the underlying nodes resources, so we can go ahead and increase the burst, and accordingly those things will be handled.
So is an Open Nebula specifically built to handle say micro VMs, or is it like a more general thing where it can handle everything? Because
not only for micro VMs,
Yeah.
for any VM infrastructure
Okay.
is what we can use Open Nebula for.
Okay. So it can, if configured, handle what the word orchestration even for like containers and stuff as
Yeah,
well.
I mean, we
Okay.
haven't explored that field particularly,
Okay.
but it should, because what we saw, it provides Kubernetes providers as well.
Okay. Yeah, that's it. Thank you.
so it,
Just to add to what he said, I think the most commonly aware comparison of this would be OpenStack, right? And in terms of orchestration, I think the more appropriate keyword here would be scheduling of your or provisioning of your workloads rather, and unless it's LXC containers or something like that.
so it, to come up with a very brief thing, right? It's like on your smaller setups, you would rather use Proxmox to run your Alexa containers, right? So it is more of an enterprise solution on the same ideology, right? So you go to your AWS dashboards, you have EC2 and all those things, right? You go there, you give a few parameters and you spin up a VM, right? Open Nebula will give you the exact same kind of functionality, right? It will give you options to run multiple hypervisors on how you can spin up. It's more of a management thing. So it doesn't give you a lot of things in terms of scalability and all those things for your particular application. That is something that you can probably work around. There are a few things called as service templates. Right? We were talking about micro VM templates, right? VM templates that you can boot up. There is also one particular thing that you can use. It's called as service template, where you can go ahead and define a lot of replica sets and all those things. Right? That is where the orchestration thing comes up. But that is a very high level feature of OpenVilla. A lot of things that are still in beta. But that, yeah, as I said, that is a particular possibility.
Yeah, hi. Hi, this is Amar here. Yeah, so my question is to Aditya. Have you explored OpenStack as well? Because that is also open source like platform.
We had that in mind, but what happened is initially we shifted to OpenNebula and solutions started flowing in for us.
Okay.
So we haven't completely shifted to OpenStack as of now.
Because that's like pretty mature. It's almost, I think so, 10 years into maturity in open source.
Okay.
You can also check how is the support for, I'm not sure about Firecracker, but it does do container and VM for sure.
Yeah, it does. Yeah. Thank you so much.
OpenStack. So probably our ideology was a bit more smaller, right? So we started using something known as FireIgnite, which is a small CLI tool that you get. You can just boot up, you use the CLI and boot up a Firecracker VM based on a OCI image, right? That is where we started. So OpenNebula was a natural increment for us. OpenShift is something that, yeah, as I said, we would go ahead and to explore. Yes, exactly. And also one of our main ideologies behind using OpenNebula was it was backed by VMware. Right? So that was one of the major things that which gave us the kind of trust that we needed to start build something. No, they actually back.
No. What I'm saying is VMware is rival to OpenStack. So they compete with OpenStack. So I'm just setting the context. I've been in this space for more than 10 years. Yeah. Thank you.
Yeah, probably that is something that we'll explore next. Okay, we have any other questions?
Hi, my question is regarding that.
To kind of interject here. But yeah, I was really interested about the billing aspect you said, right? A lot of my friends run an agency. Running something like this, and how do you kind of manage the billing? Like, let's say you have a UAT server and you have some sort of a server that you're using for a particular client. And like Amazon has like T1, T2 and stuff. What do you have some compute units that you kind of assign and say this is what it's going to cost? Okay.
I mean, we have a specific costing, say, for example, 2 vCPU and 8 GB server is something we are providing. So we have set up the cost metrics. And whenever we boot a VM using that template, so at, say, end of the month, it gives us with an entire report for the total cost that would have arisen for that particular VM, and we cost the client accordingly. Okay, so maybe we haven't, we still have to do that. Support if it's a downtime and a client comes up with that issue. Something we'll have to think about. Yes.
Ideally, yes, we would account for all the downtime. So mostly the billing aspect would go into the CPU time that is being used, right? So if there is a downtime, yes, that is something that we will account for. And
say,
since, as you said, right, in the stock, it is still in Q and UAT. That is not something that we have explored a lot into right now.
So, say, because earlier we had because we at the end we wanted something similar infrastructure. I was talking to Robin about the same. So earlier we shifted to Knative for this, and usually when we cost someone for the VM infrastructure, we cost them over the CPU, the storage disk, and the network bandwidth. So when it comes to Knative, we were trying to get those stats right from the pod level. So we were able to get the storage and the CPU things right from there. But network inflow and outflow was something that was a bit of a headache for us because of too much of noise data. Yeah, so too much of noise was present into that data. So when we shifted to OpenNebula, we saw that it provides its own billing component. So we did not have to, put our minds into how to solve that.
Hello. Yeah. So my question is regarding that downtime only. Like we know that Microsoft or Google has a lot of data center and they are much more reliable than OpenNebula. I'm not sure. I'm just quoting. So how reliable OpenNebula is? Like, can we rely on this?
Okay. So am I audible? Yeah. So as I just said, we haven't moved to production projects with this. We are still deploying QA and UAT environments. Right now, we haven't faced much of a downtime. But say, for example, a VM crashes and we implement the logic into our health monitoring service. It's a firecracker micro VM. So the downtime, if we are able to record it, will not be much.
Okay, thanks. And another for Kuldeep is that uh, in like you mentioned that in front-end security we can use a CSP, which is well aware. But don't you think while implementing CSP, we are limiting our front-end where limitations where limitations putting limitation in usage of open source resources?
Sorry, did not understand. Can you please repeat it?
Yeah, like while implementing CSP, we can make our front end that from where which data need to pick, right? So don't you think we are putting a limitation?
Yeah, I mean, it is a trade-off, right? Either we can give flexibility or we can control it. So for the security thing, we always have to put restrictions over there. That is like more preferred way.
Okay, thanks.
Do we have any more questions? Nothing. I mean, everyone got the entirety of whatever they said. No one has any questions. Can you hear me till the end? You can hear me, right? Good. So you guys have no questions whatsoever. All the things. Interesting. So coming back, right? Going through all of your talks, I have a few more questions coming back. Right? To start off with, I can probably come over to you. Right? I want to know the thought process or things that when it comes to provisioning a dev environment, right? Because the first thing that strike was whenever we are building something, dev environment is the major provisioning blocker. We'll easily get approvals for your QA, UAT, pre-prod production. All these things are pretty much set. Most of the time, we are stuck with either using Docker Compose on local or something like MicroK8 as a K3 as something that we run local, right? That is the first hurdle that we usually have whenever we provision it. So, in your journey as a tech architect, what was your thought process?
Sure, that's a great question, and you'll have to cut me off at after say 2 or 3 minutes because this is rant level material, like actually rant level material. So you'll have to cut me off in case I keep ranting on. So each team has priorities. Each company has priorities. We IoTify itself is a company in Switzerland, and it's entirely remote workforce across time zones. So ours was entirely cloud based VMs, which we were using for development as well. And our project itself is microservices architecture. And each of those have database dependencies. Some are in Golang, some are in TypeScript, some are just purely front end. So we realized our advantage as a startup is trying to minimize our turnaround as much as possible. So we wanted a very quick and effective dev environment. So if there's an issue that happens, we should be able to reproduce it as fast as possible, or even if it's a feature prototype, spin up a dev environment as fast as possible, troubleshoot it in an isolated manner, and carry ahead with whatever you're doing. So say if we are working on a microservices, apart from what we are working on, we could bring up everything in Docker Compose. That is one advantage that we had. So in terms of feature development, that's that each of our environments, we just had Docker Compose. So you bring up Redis, Postgres, various other services that we had, except for whatever you're working on, everything else is available as Docker Compose, and we had the networking as similar as possible. Now you can make the argument that the networking and certain aspects of Docker Compose is different when in comparison with Kubernetes. But luckily, as far as our use case was concerned, the transporter was over Redis or something called NATS. It's an alternative to Kafka. So we didn't run into many issues there. Networking, your L4 as far as was concerned was quite simple. Another thing is in terms of we had a sandbox environment which was Kubernetes. So feature development on Docker Compose, and then if at all some issue came up, for example, there were issues with persistent volume claim scheduling in across several availability zones. So those got caught in sandbox environments. But then again, it's still in our control, right? And only after all of this, we basically put it to production. Does that somewhat answer your question? Or I think I might have gone off on a tangent there.
So we pretty much got the idea.
Right.
So, I mean, yes, your use case actually required at dev environment to be up and running to get all of these.
Yeah, yeah. As fast a turnaround as possible, essentially.
And a lot of times in our case scenarios, other than the IoT and the main data center related stuff, right? Our main issue is basically giving out any kind of dev environment for other web applications or even a simple market where we get a few questions saying that you can run it on local, you can run it on local. Why do you need a dev environment? Why should I pay for a dev environment?
So just to add to that, we try to make it as let's say separated as possible in terms of concerns. So if you want a specific version, you could just pull that tagged image from our private repository and just bring that up. So again, you're talking about like not dedicated dev environments, but like a VM isolated to your context. Yeah, it's a hybrid approach in terms of cost, I would say.
That is something similar even we are doing. And that is where his open nebula stack comes into play.
Okay.
Whenever developers come across, like even we are working remotely, right? Developers come across saying that, okay, this is not working, or this might not work, or my laptop is going for a toss while running this or that. And that is where we come in. Okay, we need something. I mean, we'll not be paying up a lot of money for even AWS or anything to run our dev environment. That is where the entire journey of our thing started. Initially was more to provide a dev environment, which then became a whole different story altogether.
So what we have done actually, so for example, we have fixed our tech stack. That is first thing that we did. I mean, if you don't have any crazy requirement like that specifically requires a different tech stack, we don't change the tech stack. And what we have done is we have made a centralized template in our GitHub repository, right? And that is a template generator. Whatever we have to do, I mean, and we have perfected it. I mean, it is already configured with AWS, and we use EKS and all. So everything is configured, and we also have Terraform scripts as well. So for example, let's say if I have to spin up an environment, I will just run Terraform script. I will just sync it with the task definitions, and it will be up and running in general. That is one approach that we do. When we don't consider the cost factor, or if we consider the cost factor, then we have a Docker Compose file. We just spin up a EC2 machine and then just
At the end of the day,
yeah. And until it breaks, it is good at running. So it is your environment, one case. So
I think one thing that is again, sort of like referring back to the talk that I gave, is that awareness once developers understand of what constitutes a runtime environment or a runtime context. Once developers get a good understanding of that, then some of these issues will eventually solve itself. So it could be something in your bash RC, or it could be some configuration that you set somewhere else. So it could just as well be solved by you spinning up a Ubuntu container in your machine itself, and then so I think the idea is to make it as replicable as possible.
That's it. And more interesting is your setup, right? Home lab setup, right? I mean, your home lab setup is one production environment. All the things that you're migrating, doing anything, you're basically touching your own production environment, right?
Yeah.
So, I mean, what is your thought process going through your experimentations, right? As you mentioned that you usually scrape off the older deployments, bring in new technology, test it.
Yeah, maybe that was the original, motivation behind doing that. That so many times you just spin off these droplets on DigitalOcean or AWS, thinking that it's free or something. Now, as a hobbyist, that is a cost to you. Now you want to get rid of that cost. It is sort of a pinch in the pocket. on so many of our Netflix subscriptions just don't go away. It would be something of that sort, right?
Yes.
And so that was a motivation where, one Saturday I just decided, okay, let me just try this. And like he said, right, once you set up a home lab, it just doesn't stop from there. You just keep, same thing for you in the company, right? You have a private cloud setup right now. It wouldn't stop there. You will just keep upgrading.
Yes.
You just keep adding stuff to it and stuff. And one of the biggest motivations to have a proper setup is I was trying my hands on one of the security tools called Cartography. You can look it up.
Mhm.
It's from a company called Lyft, right? Cartography is a Python tool that has a Neo4j graph QLDB. And what it does is it pulls information from your AWS, your Kubernetes pods, your GitHub, your Nessus, your logging, everything, and starts forming these ingestion strategies to kind of link everything, right? So you know exactly what your Kubernetes stack is doing, and when you had a deployment where if there's a downtime, you know exactly, because you can't structure this data in SQL, you can't do it in MongoDB. You need to have a GraphQL. So Cartography was my motivation behind having like a proper powerful system to kind of try this out. Again, you need that kind of data to kind of experiment with that sort of stuff. So I started pulling in stuff from my own stuff, and I spin it off sometimes. And I was fortunate enough to kind of work on a very big project where Cartography was being used. And that was sort of the motivation. So one of the persons who used to work with Lyfts, who still contributes to that repository in GitHub. So yeah, that was mostly open source kind of motivates you to kind of do such stuff. Yeah.
Just to add that there, I'm a fellow home lab enthusiast, and I've been talking a lot to Srinivas about that as well, and it really is rabbit's hole. Once you start off, it's gonna eventually. And my home lab is named Appledore. It's a Sherlock reference. So it's another AWS Appledore Web Services. So again exposing a lot of the concepts that you would be working on your own personal time. You can understand how it would work in production. So monitoring, exposing services, firewall rules, setting up environments. We are back to there again. But a lot of those you can actually take that old laptop and then install Proxmox or KVM, or just get started somehow. It's quite empowering. You actually get to understand how DNS works. Like half of your issues are DNS related. You can set up Pi-hole, ad blocker for your entire network, right? That was quite cool. And backups. You get to think of it from an enterprise sort of aspect of it. Like for example, my website is served from my apartment, and in case my power or internet connection goes, it fails over, it gets rerouted to another Linode instance. So it's over engineering, but it's like the most beautiful form of over engineering, right? Home lab enthusiasts are the best over engineer.
Started off with the basic setup, and now as day grows by, the complication increases.
Yeah. Just start off. It'll just pull you in.
Even I'm actually a home lab enthusiast. Right?
Awesome. We should.
Even I have a setup at my home, but my setup is mostly refurbished. I don't have an extensive setup. My setup is actually running on a very old Pentium 4 system. Right, so whatever we had available, right? So that is something uses the age-old DDR2 RAMs, the 80 GB SATA hard drive. Pentium 4, for the first time they had brought in hyperthreading.
Okay.
It's
Gen
a
4
very old classic setup.
Good.
But
you get to test your stuff under resource constraints.
Yes, pretty much everything is running on that. Like we have distro, Ubuntu.
Right.
So that is the one that I use on that particular setup.
Awesome.
It's also pretty much what you call resource constraint, and also that particular system is still 32-bit.
Oh, okay. So
it's a whole new thing out there for
that's
me to.
an additional Pandora's box.
So a lot of things, right? I also have a set of Raspberry Pis where I also have Pi holes.
Awesome. We should have a home labbers meetup.
Yeah, it's actually one thing. It's actually one thing that we are looking for.
Awesome. Let's do it. I think we have it.
Yeah, you had something?
We distracted you with Home Lab.
My question is another micro VMs thing only. So one thing I kind of need to understand is what is like the smallest unit or a smallest entity you would consider you can deploy in a micro VM. For example, what I mean by that is you take Docker Compose, right? If you take a Docker Compose, you can basically define pretty much everything required to run your software, front end, back end, Postgres, right? Simple. So when you look at it in that terms, what would you say is like the lowest entity that a micro VM can represent?
One microservice per micro VM.
Okay, so if let's consider we have a Docker Compose file that has 3 services: a Postgres, front end, back end. So you're telling me that a micro VM can basically be front end, the back end, and maybe even can I run Postgres in a micro VM?
Yeah, you can.
Okay. All right, fine. So I read somewhere, and maybe you can enlighten me on this. Because my assumption before this talk was basically like micro VMs, you can think of them as because I was aware Lambda functions kind of run on this. My assumption was like they were more like for Lambda functions itself, where you can just spin up for like one isolated instance thing.
So again, to comment onto that, what I can say is Docker Compose. Say for example, you are using for your non-production environments, right? When you are moving into production, what you are using proper stateful managed services. So this is what you can do here as well. When you move to production, you can have dedicated servers where you can go ahead and boot your VMs. Your stateful applications. For UAT and pre-prod environments, you can still have the Postgres instance running inside your VM, micro VM.
And I have another question for Srinivas and Robin, basically, or any home labber here in general. What do you think about what's happening with Ansible and Red Hat and everything, right? Because I'm kind of certain every home labber has like the same opinion on that. I just wanted to ask.
I think it's not cool, and I think Jeff Geerling had the best reply to that. So, just for context, Jeff Geerling is very experienced and a very core contributor to the Ansible project, and he had written a definitive book on Ansible. So he open sourced his book and just said, "You guys can copy Red Hat. Hey, Red Hat, you can copy this if you want." So I think anybody working on the open source ecosystem would be a bit concerned with what happened, especially the Red Hat model, right? So I think it's good and keeps us on our toes to invest in backups and alternative distributions and always have a contingency plan. And in that way, it makes us a bit more alert. And I think it would have the community's guard up a bit when making design considerations and choices. But then again, corporate world stuff happens.
RACL, we had CentOS. After CentOS 7, they just closed down the entire open source.
Yeah, right. Yeah.
Yeah, I mean, we were just talking about it, he brought it up when we just met, and what's happening with Red Hat? I'm like, not good. But then again, I think we sort of saw this coming when IBM kind of took over. We saw that, enterprise has always mean greed and stuff. And Red Hat being like, for the longest time, they've been doing only good stuff. CentOS, and they also used to, Fedora was amazing as well. They kept contributing so much. Whatever went into Fedora got tested for a while, then that went into like Red Hat and stuff, right? So a lot of, I don't know how many of you know about OpenShift, which was also Red Hat stuff. One of the very early on, cloud solutions which you could put on your private cloud. They had this concept of cartridges and something I can't remember, which was basically compute power with RAM and CPU, where they first coined that word, right, which others kind of picked up. But now I see it's going down the drain. But I think as a good thing, OpenSUSE has recently kind of come up with a project where they're gonna kind of pick that pace up, and OpenSUSE is kind of doing some good stuff there. So yeah.
I guess.
Yeah, so I have one question to the home lab guys here. So what's the cost of your setup? because all of the people in the crowd are cloud users, just to get a context so that everyone knows how much they're paying for the cloud compute and how much does the home lab one time cost.
Yeah,
That's exactly it, right?
No, but what's your cost? Yeah, that's the point. His point is valid. I
I
know.
would rather not. I mean, I never say this. I usually say any questions about a good question, but that is a very bad question. I am. Let's just say I'm not at liberty to disclose.
That's why I got it. It's pretty expensive. So Srinivas, what's your
It
home
gets
lab
expensive
cost?
very
Yeah, pretty expensive one, yes.
I think I can expose not too much. I started about spending 25 grand, and then I put another 10 grand. By the time I was done with it, I ended up spending about 40 grand. But on a good note, like home lab is expensive to set up in a certain way, but in a long run, I'll be saving a lot. So it was like a good investment.
Yeah, pretty nice.
So just to add to that, since we are recording and there might be people watching this afterwards as well, on the note of it can be as expensive as you want it to be or as cheap as you want it to be. Raspberry Pis are quite expensive these days, but Raspberry Pi alternatives or like a second-hand laptop. One of the most realistic things is like a refurbished computer you can get on Amazon refurbished, or like even if you're in Bangalore.
SP Road, yeah. SP Road, we can get.
Yeah, you can SP Road, exactly. You'll get like a lot of secondhand. Get something that's say above 5th generation with some DDR3, DDR4 RAM, and you can kit it out yourself. I myself started off with a Ryzen 3600 and the cheapest GPU, just because I wanted to get a display output. Started off with 8 GB RAM. That 8 GB became 16. 16 became 32. Started with 512 GB of storage. That became 1 TB, then 2 TB, then 4 TB. It keeps adding. Don't worry about it. Don't think too much about it. Get started. It'll keep expanding on its own, and you won't be able to. It's a problem, guys.
It's not an upfront investment. You start off with as little as 5 or 6,000 on Raspberry Pi, and sometime 5-6 years down the line, you would have end up spending anywhere around 2 to 3 lakhs across. I mean, that still would be fine.
And anyways, MacBook Pro is 2 lakhs, yeah. So,
But the
just to set the
advantage
context.
so two things to that. There's a great degree of freedom. I think yours is still your daily machine, right? So there's a certain degree of freedom that comes with having an environment you can completely wreck. So I can't do that with my daily driver machine. But if it's like a dedicated machine, you can of course like try new. If you're distro hopping, you can of course distro hop. But having a separate machine or a separate hour to help with that kind of helps. Another advantage is it need not be the latest. It can be outdated, second hand. It's not critical, mission critical stuff, right? So, and Linux is very light.
So yeah, I guess that would be it for today's evening. Right. Thank you guys all for joining in. Right. Good night.